Now we'll discuss the question number 45, and it is from welding. And the question is, a welding operation is being performed with a voltage of 30 volt and current 100 ampere. The cross-sectional area of the weld bead is 20 mm square, and the workpiece and the filler are of titanium, for which the specific energy for melting, that is heat required, it is given as 14 joule per mm cube. Now assume a thermal efficiency of the welding process is 70%. So heat transfer efficiency it is given. So the welding speed in mm is, so we have to find out the welding speed. So first we will write down the given data. So given data, we have voltage which is equal to 30 volt, current which is equal to 100 ampere, then cross-sectional area of the weld, it is given as 20 that mm square, and specific energy which is equal to 14 joule per mm cube, and then heat transfer efficiency which is equal to 70%. So we have to find out the welding speed. So we have to find out the welding speed in mm per second. Now, a specific energy it is given as 14 joule per mm cube. So we'll write down this 14, which is equal to that V into I upon this weld area into welding speed, which is multiplied by the heat transfer efficiency. So that is your specific energy, which is equal to that voltage into current upon that weld area multiplied by the weld speed. So obviously this 14, which is equal to voltage we have 30, multiplied by current we have 100 ampere, and weld area we have this 20, multiplied by welding speed, which we have to find out, multiplied by this efficiency, which is equal to 0.7. Now if you will solve this, you will get welding speed which is equal to 7.5 mm per second. So this is generally this heat input in joule per mm cube. So for that we have to divide that Vi upon V by that weld area. So you will get that weld speed which is equal to 7.5 mm per second.